If you ask a primary school kid or a junior high school kid and ask them what are atoms, and they would probably say that atoms are kind of a tiny things that is about everything about matter. And they would even say that you have protons and neutrons in the middle, and we have electrons and around. So many of us know that the neutrons and protons are in the middle, in the nucleus, and we have got electrons, and some would say they are in orbits, and some would say they are like a cloud. So depending on their understanding, they would say different things. So over the last couple of 100 years, that the way that we have developed our understanding of what atom is and how matter is made of. So John Dalton was an English scientist that he came up with the idea that atoms are like these small things that in matter you have got different atoms. So he said that different atoms will have different size and different mass, and that was his idea. And then here came Thomson, and Thomson found out electrons, and so he came up with this model of a plum pudding model. It's just like a cupcake where you have got a cupcake where chocolate chips in it. So he called these chocolate chips as electrons, and the rest of the cupcake as a positive thing, and that is equally distributed. That's called a plum pudding model. And then another scientist called Rutherford and his friends, they did an experiment, and they sent the alpha rays towards a gold plate, and they found out that lots of rays were going through it and some of them were deflected. So he came up with this idea of an atom where you have a positive mass or positive nucleus at the center, and he found out that the mass is focused only at the center, and we have electrons orbiting the nucleus. Then we had other scientists like Niels Bohr, Heisenberg, and many scientists did lots of work and came up with different models. But in the last 150 years, that scientists started to observe the different behavior of atoms and how it's behaving, and the forces in the universe, like gravitational force, we have magnetic force, electromagnetic waves. So they came up with a model that basically explains everything. I mean, they're still trying to find lots of different particles, but they come up with a model that contains of these 3 different types of particles. One is like the static particles that are responsible for mass and all those things, and there are particles that are responsible for the fundamental forces like gravitation or electromagnetic force. So that model is what we use at the moment as an acceptable model, and that is what we are going to discuss now. So let's start with the original model that we talked about, how the high school kids, not the high school kids, I would say primary school kids, they talk about this atom. They say that this is an atom, and they say that there are electrons, and they also say that we have protons and neutrons in the middle. So these are protons and in a different color, neutrons. So let me label them like this is electrons, protons, and neutrons. So in the last 100 years, that during the lots of developments, they have found out that these neutrons and protons are something inside them. They are made up of some of the particles. So they came up with these particles, like for instance, for neutrons, there are particles called quarks. So there are 3 quarks in these neutrons, and there are 3 in protons. They are called quarks. So this one. So you would see that these protons have got 2, they called it up quarks because you can see it's upward, and these are called down quarks. And these neutrons have got 1 up quarks and 2 down quarks. we know that proton has got a relative charge of +1, and neutron has a relative charge of 0, and electron has got relative charge of -1. So these quarks have charge, because we know that proton has got 2 up quark and 1 down quark. So they found out that up quark has the charge of +2/3. That means if you have a proton that has 2 up, right? So that means it has got +2/3, +2/3, and they actually came up with the down quark having -1/3. That means this is -1/3. So how much is that? 4/3. That's 3/3, which is equal to +1. That matches with this value. So the proton has got +1 that are made up of these quarks, has got these 2 up quark and 2 down quark. And let's look at what we have put for the neutron. So neutron is 2 down quark, right? So -1/3, -1/3 plus 2/3. So that is 0. So they found the charge for these different quarks. Just like these up and down quarks, so they also found another 4 quarks called charm, strange, top, and bottom. I mean, they are the names they gave to these, so they are quarks. So these quarks, we looked at up and down, which actually the fundamental particles or the elemental particles within neutron and proton. So they have got up, down, and there's another one called charm and strange. It is strange. And also top, bottom. So these are the quarks that are part of the standard model. So the standard model has got all these ones: up, down, charm, strange, top, bottom. So now we know that an atom, the nucleus, and they have got electrons, but the protons and neutrons inside, they have got other fundamental particles. So those neutrons and protons are made up of these quarks. So quarks is something that play a significant role in the standard model. And how do they find out these ones? Well, if you throw a coconut, so you have a coconut and there's another coconut, and if you throw a coconut and another coconut, what will happen? The coconut will scatter into small pieces, right? And then you can find out what's inside the coconut. And that's what exactly they do with atoms and particles. So you can get the protons and neutrons as separated from atom, and you can make them to collide with each other. You can make them to collide with other atoms or another objects to find out what is inside protons and neutrons. So we call these particle accelerators, where you accelerate particle at a very high speed, close to the speed of light, and make them to collide with other particles or another object and scatter them. And then you find out what is inside those particles. And that's the way they found out that all these quarks and other different particles. And also, when you accelerate particles and collide with them, sometime these small particles will combine together. Like, say, for instance, you have got these up and down quarks and charm and strange and top quarks and all these quarks. Sometimes these quarks will combine together and form another particle, something else that we will be looking at later. Just like neutron and proton, there are some particles are formed from these fundamental particles during the collision, but they don't live forever. They just decay after some time. So you can't see them after a certain time, and they will decay. So these protons and neutrons have got quarks, and you can't divide quarks into anything else. Electrons, that's we see here. Electrons, we find that they are not really particles, they have got wave properties as well. And the electrons can't be divided into other smaller particles. So electron is also a fundamental particle or elemental particle. So fundamental or elemental particle is a particle that you can't divide into something else. Proton and neutron are not fundamental because you can divide them into quarks. So these protons and neutrons, we group them and we call them baryons. So we have a name called baryons. Baryons is like a team of people. So these protons, and we call them protons and neutrons, are called baryons. And just like these baryons, there are other particles that we talked about here, that sometimes that two other quarks can form another particle. They are not fundamental. We call them mesons. So that's another name. So mesons. So mesons and baryons are particles that are formed from quarks. So baryons, you obviously know that they are formed by 3 quarks, and mesons are formed by 2 quarks. And electrons, these ones, we call them leptons. So that's another name for electrons, leptons. So that is leptons. So we got lots of interesting names here. We got quarks, up, down, charm, strange, top, bottom. They are the small ones within quarks. And protons and neutrons, we call them baryons. And the other particle formed by 2 quarks are called mesons. And both these baryons and mesons together, we can call them hadrons. So these two, we can call them hadrons. So hadrons are baryons and mesons. Baryons, we know they are neutrons and protons, and mesons, there are particles that we're not going to discuss here, but they are called mesons. They contain 2 quarks. And electrons are leptons, but there are other leptons as well. We have got muons and tau are other leptons. Just like these electrons, we have got muons and tau. So these electrons and muons and taus, you can't divide them into other smaller particles. So they are also fundamental particles. And like these electrons, we have got another particle called neutrino. So neutrino is another smaller particle, and we have got that neutrino for every one of them. Like muon, we have got another neutrino called muon neutrino. And we have got a tau neutrino. And we have got an electron neutrino. So altogether, we have seen there are 6 fundamental particles. They are the quarks. And there are 6 of them here. These electron neutrino, muon and muon neutrino, and tau neutrino. There are 6 leptons. So we call them leptons. And these 6 leptons and 6 quarks are part of these standard models. And then we have got this team. They are called the teams, like a football team. So baryons are the protons and neutrons. And mesons are the one that has got 2 quarks. Actually, we can write those names as well. There's one called pion that has got 2 quarks. And there's another one called chion. So pion and chion have got 2 quarks, and we call them mesons. And mesons are particles that are created during collision. So these nuclear transmutations, but they decay quicker. But protons and neutrons are something that we always know that they are there, and we know what they do. So just to summarize what we have looked at so far, the nucleus, we got neutrons and protons. And neutrons and protons are made of quarks, up quarks, and down quarks. At the same time, we have got other quarks like charm, strange, top, bottom. So there are 6 quarks. And these are called leptons, electrons, muons, and tau. And there are neutrinos, muon neutrino, electron neutrino, and tau neutrino. All these 6 are called leptons. And then we have got baryons and mesons, part of hadrons. So let's look at everything together in one place. And before that, these particles have got mass and they have got charge. And there are other particles called bosons. So that's another primary one, fundamental particle called bosons. So what are these bosons? So we looked at these different particles, these quarks and leptons and everything. They're not static, but we are not talking about forces. We're talking about mass and charge. But if you look at this nucleus, there are positive charges. But what do positive charges do? They repel, because positive charges, they don't attract, they will repel. So if you have got so many positive charges, if you think about repelling, we can't have a stable nucleus, right? So there must be a force that's keeping all these charges together. So we call it a strong nuclear force, and there is a particle that's responsible to keep those charges together for the strong nuclear force, and we call that gluon. So that's a force particle, it's a vector. And we have got another particle called photon. That's the one responsible for electromagnetic force in the universe. And then we have got, just like the strong nuclear force, we have got another one called W and Z. And these are for weak nuclear force. That means they are kind of forces that we have between the electrons and the nucleus. So that is supported by this weak nuclear force. And there's another one called graviton. So we call it graviton. The scientists haven't found that yet, but just to complete the standard model, that they have come up with this graviton that's responsible for gravity in the universe. So these are the 4 bosons particle: gluon, photon, and we have got W and Z, and then graviton. And 2012, only recently, that scientists discovered another one called Higgs boson. So there's another one called, let's write down here, that's called Higgs boson. So Higgs boson is an interesting one, because that Higgs boson is a scalar boson, and these are vector bosons, because these are responsible for forces, like this one for strong nuclear force, and this is for electromagnetic force, weak nuclear force, and this is for gravity, which we haven't found yet. And Higgs boson is the particle that gives mass to particles. So this is a scalar one. So let's look at everything that we looked at in a proper chart. So this chart shows everything that we discussed. So these up, charm, top, down, strange, bottom are the quarks, the fundamental particles that is making the protons, neutrons, which are called baryons, and also the mesons. So for baryons, we need 3 of these, and for mesons, we need 2 of these. So if you look at a proton, you have got 2 up and 1 down. And if you got a neutron, you have got 1 top and 2 downs. And mesons is a combination of 2 quarks. So that's making the hadrons. So hadrons are baryons and mesons. And then we have got leptons. So leptons, the main ones is electron, and with electron we have got an electron neutrino. And muon, we've got muon neutrino, tau, and we've got tau neutrino. And this is the one that we normally come across, but many of these ones are temporary. Like they don't, their lifetime is very, very low compared to electron. And these are the bosons. The gluon is responsible for the strong nuclear force and photon for electromagnetic force. Z boson and W boson are the one responsible for the weak nuclear force. And Higgs boson is the one that scientists discovered in 2012, although it was predicted by the scientists long before that. And they found that this particle is responsible for the mass. So this is a scalar one, and these are the vector ones. There's another term that we use is called fermions. So is fermions. So the quarks, which basically makes up all these baryons and mesons. So these quarks will make baryons and mesons, which are hadrons, and also these ones are called leptons. So fermions is basically all the hadrons. So all the hadrons and Fermi and the leptons. All the hadrons and leptons are, there's another word, fermions. So that basically conclude that explanation of standard model. There's lots of things to remember, but I think that these are the terms that scientists came up with to name these particles.